Hello and welcome to another video by Training Made Clear on the Imperial and the Metric System. Today's lesson will be lesson number 6 and it's about volumetric flow. We are affected by these two systems, the Imperial and the Metric System, shown in the 8 lessons below. Today's lesson will be number 6 on volumetric flow. If you remember in lesson number 3 about volume, we discussed what volume is defined as. Volume, a simple definition. Volume is the measure of the space inside a container or inside a solid object. Another good definition would be volume is the amount of space an object occupies, measured in cubic units like cubic meters or liters. Volumetric flow, what is it? Volumetric flow is the rate at which volume passes a point per unit time. In all systems, the idea is the same. Volume divided by time would be equal to the volumetric flow rate. Q would be the volumetric flow rate, V would be the volume, and T would be time. What differs is how volume and time were historically defined. In the metric SI units of volumetric flow, the primary SI unit would be cubic meter per second, written M3/S. Definition based on the meter length. Volume equals length times length times length. That would be this M3. And T would be this S, which is seconds. The flow rate formula, Q is equal to A times V, where Q is the volumetric flow rate in meters per second, A is the cross-sectional area of the pipe in meters squared, and V is the average fluid velocity in meters per second. If we look at the common metric flow units, and we look at the relationship, 1 cubic meter is equal to 1,000 liter. 1 liter is equal to 10 to the minus 3 cubic meters. Key feature of metric is that it's entirely decimal and has easy scaling, 10 times 100 times 1,000. If we look at the table below, we have units, the meaning, and the typical use. So, for the unit cubic meters per second, it's written as M3/S, and it's talking about typical use in engineering standards. Cubic meters per hour is written as M3/H, and it's used in water or HVAC systems. Liters per second is written as L/S and is used in plumbing or lab work. Liters per minute is L/min and it's used normally in medical or pumps. Milliliters per second is mL/S and it's used in dosing systems. The Imperial English units of volumetric flow. Imperial units come from older trade and daily use volume measures. Common imperial flow units. Cubic feet per second would be written as FT^/S or CFS, and is used in rivers or drainage. Cubic feet per minute is FT^/min or CFM, used in HVAC and ventilation systems. Gallons per second would be written as GAL/S, used in large flow systems. Gallons per minute would be written as GAL/min or GPM, and it's used in plumbing or pumps. Gallons per hour would be written as GAL/H, and it's used in fuel or metering. Side-by-side comparison of the metric versus imperial. If we look at the base length for metric, it's meter, and for imperial, it's foot. The base volume is meter cubed for metric and foot for imperial, foot cubed for imperial. Time base is second. Imperial is second per minute. Scaling for metric is decimal. For imperial, it is fractional. Standard unit, meters cubed per second for metric and foot cubed per second for imperial. Ease of conversion for metric is high and for imperial is lower. A visual comparison, same flow, different units. So if you look at 1 meter cubed per second, would be the same as 1,000 liters per second. I've made the yellow to represent the metric system and the green to represent the imperial system. So looking at 1 cubic meter per second, it's metric. The 1,000 liters per second is still metric. 3,600 meter cubed per hour is still metric. But the next three are the imperial equivalents. So 1 meters per second, 1 meter cubed per second is equal to 35.3 cubic feet per second, or 2,119 cubic foot per minute, which is CFM, or 15,850 gallons per minute US. The historical origin of the metric system. How metric units were determined. The metric system in the late 1700s in France was designed to be universal, scientific, and decimal based. Key ideas: volume was derived from geometry, not containers. Time based on astronomical seconds. The result, volumetric flow became length cubed divided by time, which equals meter cubed per second. Flow units were calculated, not measured by containers. The historical origin of the imperial system. How imperial units were determined. Imperial units evolved from everyday life and trade, not science. Volumes came from gallons. Gallons of wine, gallons of ale, gallons of grain. Cubic feet was the physical space. There were buckets, barrels, ladles. Time came from minutes and hours, work-based timekeeping. The result, flow, was defined as container per time, gallons per minute, cubic feet per minute. Flow units were measured by containers, not equations. Why the two systems feel different. Metric asks, how much space passes per second? The metric system, flow equals geometry divided by time. Imperial asks, how many known containers pass per minute? Both work, they simply come from different worldviews. The imperial system says flow is equal to container divided by time, like gallons per minute. Practical examples. Let's take a look at a river, HVAC, air, water pumps, and fuel flow. For river, the metric is meter cubed per second. Imperial would be cubic foot per second. HVAC air is metric is cubic meters per hour, and imperial is cubic feet per minute. Water pumps, metric would be liters per second, and imperial would be gallons per minute. Fuel flow metric would be liters per minute, and imperial would be gallons per hour. So a summary table. If we look at the aspect, which would be metric and imperial, the origin for metric is scientific. Imperial, it is trade and craft. The base idea for metric is length cubed divided by time. Imperial is volume container divided by time. Consistency for metric is high. For imperial, it's mixed. Modern global use for metric is yes. For imperial, it's limited to US and UK. One line takeaway. Metric volumetric flow units are mathematically derived from geometry, while imperial units evolved from practical container-based trade measurements. Here is a volumetric flow ruler. I won't go through all of the different scales here. Just have a look. The metric scale, meters cubed per second and liters per second, the different values. So if you look at, for instance, 1 liter per second would be equivalent to 0.001 cubic meters per second, whereas 1 cubic meter per second would be 1,000 liters per second. If you look at the metric practical time-based, liters per second, if it was 1, it would be 60 for liters per minute, or 3.6 for cubic meters per hour, and so on. They would just get bigger and bigger, multiplied by 10 every time. Right, the imperial scale, US customary. If we're talking about cubic feet per second, then when you've got 1 cubic foot per second, you've got 450 cubic feet per minute. If you go up to 10, it would multiply the 450 by 10, and you'd have 4,500 cubic feet per minute. If you look at the gallon-based US, gallons per minute on the left would be imperial, and liters per second on the right would be metric. So 1 gallon per minute would be the same as 0.063 liters per second. 100 gallons per minute would be 6.3 liters per second, and so on. Key takeaway. Volumetric flow rulers let you translate the same physical flow into different unit systems without changing the physics. There is a single anchor comparison, and use it for a memory point. Here we have 1 cubic meter per second, and it's yellow, so it'll be talking about decimal value, and the next two that are in yellow are the decimal equivalent. So 1 cubic meter per second would be 1,000 liters per second, or 3,600 cubic meters per hour. Or it would be the same as the next three, which are imperial, and that would be 35.3 feet per second, or 2,119 cubic feet per minute, or 15,850 gallons per minute. How to read the rulers? Move vertically, increase in flow. Move horizontally, same flow, different units. Metric scales increase by powers of 10. Imperial scales increase by practical quantities. This table that we're looking at here is basically the flow ranges and the typical applications you would see them being used in. So when we're looking at a flow range of milliliters per second to liters per second, we would see this in medical dosing. And if you look at the diagram, you can see there a drip feeding into a person's arm. That's a very low flow. Liters per second to meters cubed per hour, it's used mainly in plumbing or HVAC. So you can see there's the HVAC, the air ducting system, and we're measuring the airflow. Meter cubed per second would be used in rivers or cooling water. There you can see a picture of a cooling tower, and that is where we would use cubic meters per second. CFM would be used in air systems. So if you look at an air conditioner, for instance, that would be where you'd use CFM. GPM, which is gallons per minute, and that is used in pumps and piping. You can see all the blue pumps there. Okay, if you liked this video and learned a lot, please show that you like it, subscribe to it, share it, and comment on it, and follow if you can. And thank you for watching.